Hey coders, in this video we are going to take a look at a topic that has to do with Boolean logic. It basically has to do with when you write an if statement and you have multiple conditions inside of it, you usually have more than one way to write it. So it's easier just to show you by example here. Here I have a Boolean A, Boolean B, and I have an if statement here. So I say if A and not B. Now the only way that this becomes true, so it prints out the yes, is when A is true and when B is false. Now, if you're not convinced by that, you can run this program a few times, run it with true and true, run it with true and false, false and false, false and true, whatever. Do all four combinations, and you notice, right, it's an and. A has to be true, and this part has to be true, which means B has to be false. Now, some people are really good at doing these in their head. Other people literally have to write out a little grid and test the conditions out really slowly. As you get better at them, you'll be able to start doing them in your head a little bit more. Now, what this DeMorgans Theorem idea here is, it's a bit about the logic. It's about the alternative or equivalent ways you could write the statement. So what I've done here is I have the exact same if statement, right? So it's going to do the exact same thing. But here's a different way to write it. And this is a little bit like math where you factor things out, but check this out. Out of the A and the not B, I'm going to do what I call factoring out, a not symbol. So I'm going to factor out a not symbol out of there. And when I take the not symbol out, that means that I've left a not symbol there and a not symbol there. Now, if this seems a little bit weird, oops, let's do that. If this seems a little bit weird, just consider this. Not applied onto a not is not, which cancels out the not, all right? You're just left with A, okay, or whatever that Boolean value is. When you have a not symbol applied onto the B, that's not B, okay? And that works. Now, there's one rule, though, when you do this. So literally, you saw there how I've not is an A, not times the B is a not B. But to make this actually work, so it's the equivalent, you have to change your and to an or. Or if it was an and symbol, you have to change it. Sorry, if it was an or symbol, you have to change it to an and. That's the price you pay for doing what I call the factoring out. Now, if you actually test this, you're going to find that it is exactly the same as this one up here. Okay, the same condition, A of true, B of false, is the only way you're going to get yes to print out. Okay, so if you look at that again, if you just do it, A is true, so not true is false. Okay, so we have a false. B is false, false. So we have false or false, which is false overall, and then not false is true. So, and when it's true, it'll print out the yes. Now, if that's a little fast for you going over it here, it's hard to do this one on the screen, right, without pointing and drawing a lot. But you'll see that these are equivalent statements. Even if I wanted to go backwards here, look at this. Not times a not gives me A. Not times a B gives me the not B. So I've just applied the not symbol onto these two, but the rule is you got to switch whatever you have. And so you can go forwards and backwards with this, what I call the factoring. And you'll see we have the equivalent condition again. Now I'll just put that back to our answer there. So it looks like that. Now if you actually give this a run, which I have, it works out perfectly. And you'll see that it always prints out yes or no the same, regardless of what true and false values you put up here. Okay, they're equivalent. Here's another little example here, example 2. Let's say at some point you're doing some condition that says if not this or not that, print out yes. Okay, what would be the equivalent? And you'll see it right down here. Okay, so basically what I did was I factored out the not symbol. So when I pull the not symbol away, I'm left just with A. When I pull the not symbol out of here, I'm left just with B. And switch my or to an and. And so when you say not A or not B, that's the same as saying not A and B. Now, some of you will just hear that and it'll make sense in your head. Okay, small fraction of students. And then there's some students that just, hearing it doesn't make sense. You sort of got to take a little longer and do it on the paper and just have trust in the rules. But if you actually do the table for this, you're going to find that the way to get true out of this is to, and there we go, I just jumped ahead in time. Here's basically a little table I made. So I worked off this one just off the top here, how to get the yes. To get the yes, A if false, B is true, gets me the yes. False and false gets me the yes. True and false gets me the yes. And true, nope, does not get me the yes, okay, gets me the no. When I go and test it out for this one, after I've applied little rules and just changed it up, you'll see the exact same table works. When the two tables for each condition are the same, okay, same results, you know you've got an equivalent Boolean condition. Now, which one do you like more? Well, here's the thing. You may think that one reads easier, or you may think that one reads easier. It's sort of up to you. At this point, this one's pretty simple. Each one should be easy enough to understand. But where the benefit comes, and I'll just jump to it now, is it comes to when you're actually designing the circuits for these in electronics. So the people that are into making the circuits that'll actually make your Boolean conditions work, they got to code pathways and pieces to make this happen with electricity and wires and transistors and gates. Sometimes one path is easier to code than the other. And so when you actually go to make these, the electronics person, when they're trying to code like a situation like this, right, which is not A and B, so a NAND gate, is this one may be easier to draw out in circuitry than this one is. Okay, it's easier to do the negative of the AND than to do the OR with two negatives. And it doesn't really matter for your coding now, but just to give you an idea that the stuff is actually useful at some point and when reading your code. I'll just go forward with two more little examples here just to make sure you sort of get the basics. But here's one where the user has to enter Y or N. When they're asked to enter a yes or no, but maybe they enter X or Z. Here's a little if statement, right? If they didn't answer Y and at the same time they didn't answer N, then please select Y or N. Okay, this is a little check. If we just follow our rules here, let's do the same thing here. Let's factor out the not symbol. So I factor it out, put it in front, and what am I left with? I'm left with if not, and it's been stripped away from here, so answer equals Y. I change my AND to an OR. I take the AND not symbol away from there. These two are equivalent. So now it basically reads, if not, did they answer yes or answer no? So for some people, they actually like writing it like this a little better, right? Not all the possibilities. Here's one with age. That's a little weirder. But you'll see here I've made this complicated, right? I mean, it looks so simple. If you're less than 16 and your IQ is less than 75, you can't drive. This is what happens when I apply that little rule. It looks like a mess. But here's one thing. When you actually have a condition like this and you have the not symbol, well, not age less than 16 is really the same as saying age greater or equal to 16. And not less than 75 is really the same as saying IQ greater or equal to 75. So now it depends which way you like. So if it's less than 16 or less than 75, you can't learn to drive. Or you can say if not 16 and IQ 75 or higher, you can't learn to drive. Debatable, right? I like this way. Some people may like that way. Anyways, that's your sort of basics. Can you look at these two here and convert these two? I'll let you pause right now, and in 5 seconds I'll put the answers up there. And there you go. There's the little answers there. The AP exam has a few of these questions every year, 2 or 3. They slap it on where you're asked which statements are equivalent. So the long way is to do a table and just write the results for each one, and hopefully you spot the one quickly that's the same. The other way is usually applying these rules DeMorgans Theorem, and you can quickly change them up, and usually one of the answers stands out right away. Anyways, there you go.